Let's take a look at this problem. If Angela has $100 to invest at 10% per annum, compounded monthly, how long will it be before she reaches 175? Compounded monthly. So n is equal to 12. The formula we want is a is equal to p times 1 plus r over n to the nt power. $100 to invest. That means principal. So p is 100. 1 plus 10%. That's 0.10. N is 12, they told us, to the 12t power. How long before it gets to 175? So a is going to be 175. Well, this is an exponential equation, so we want to solve for the variable. First step, get the part of the variable and the exponent by itself. So I divide both sides by 100. So 175 divided by 100 is equal to 100. 1 plus 0.10 over 12 to the 12t power divided by 100. So those cancel. Now this one works out pretty nice. If I would put that in my calculator, 175 divided by 100, I'd get 1.75. So I might as well simplify that a little bit, make my life a little bit easier. 0.10 over 12 to the 12t power. Step 2, take natural log of both sides. So we got natural log of 1.75 is equal to natural log of 1 plus 0.10 over 12 to the 12t power. Step 3, use properties of logs to get the variable out of the exponent. So I'll take the 12t and put it out in front. Natural log of 1 plus 0.10 over 12. We want to solve for t, so we're going to divide both sides by 12 natural log of 1 plus 0.10 over 12. What's in front of our variable and what's after our variable. And do the same thing to this side. There we go. When I do that, these 12 is going to cancel, and these natural logs will cancel. And we're left with t. Now we're ready to plug that in our calculator. Now the trick is, if you got more than a single number, a single variable, a single log on top or bottom, you have to put parentheses around it. So we have to put parentheses around the bottom. Now if you're not sure about the top, go ahead and put parentheses around it. It doesn't hurt anything. Okay, so we got natural log of 1.75, close parentheses, divided by, beginning parentheses on denominator, 12, natural log of 1 plus 0.10 divided by 12. You can put closing parentheses if you want at the end, but you don't have to. Closing parentheses on log, closing parentheses on denominator, and press enter. And we get 5.62 years. Okay, let's look at the continuous case now. As it says, if it's compounded continuously, how long will it be? That's our PERT formula. A is equal to P e to the RT. And let's see what they give us. Angela has $100. So P is 100. E, 10%, so that's R, 0.10 T. And we want 175. Again, this is an exponential equation, so we're going to get the part of the variable and the exponent by itself. That's step 1. So divide both sides by 100 again. There we go. Now over here, 175 divided by 100, we already said was 1.75, so might as well simplify that a little bit. On the right side, these hundreds are going to cancel. And we got e to the 0.10 t power. Step 2, take natural log of both sides. So we got natural log of 1.75 is equal to natural log of e to the 0.10 t. Now step 3 is use properties of logs to get the variable out of the exponent. Well, remember, for natural log, your base is e. So if these numbers match, these e's match, the log and the e is going to cancel and leave us your exponent. So this will be 0.10t. Divide by both sides by 0.10. You don't need to put trailing 0 on at the end if you don't want. These 0.10s will cancel. And we got t is equal to whatever that gives us. So let's see. Natural log 1.75 close parentheses divided by 0.10 or 0.1. Enter. 5.6 would be our answer.